Example 11 is a pretty special example for multiple reasons. First and foremost, it's the first time we have seen the word log exist more than once in any of the problems that we've worked with. In terms of our steps say to isolate, right? Isolate the log expression. Well, since there's two of them, we have to isolate in part by making it into one. So when we go from two logarithms to one, that's through our condensing process. So since these logarithms are currently being added, we can condense them using multiplication of the two arguments. So we want to condense from two logarithms to one using our condensing rules. Now I can go ahead and rewrite x times x minus 2. I could even do that in my very first step, making it x squared minus 2x by distributing that through if I would prefer. So either of my purple steps can be written as your first step. So once I have it isolated, because it's down to one logarithm, then I'm going to do the rewrite. So I'm going to start with my base 4, cube it, and raise it to x squared, and then set it equal to the argument of x squared minus 2x. Then I'm going to go ahead and make 4 cubed 64, and I'm simultaneously going to move that 64 to the other side. And the reason I want to do that is because I have a quadratic expression. And so I'm either going to need to factor this quadratic expression, or I'm going to need to potentially use quadratic formula. So in terms of factoring, I'd look for two numbers that have a product of negative 64 and add to negative 2. If I don't feel comfortable with that option, I'm going to pretty quickly realize that the quadratic formula is a good place to go. So pause the video for a moment and use the quadratic formula to see what you get. So I've written a quadratic formula because I think it always helps to start there. I'm going to substitute in the opposite of negative 2, plus or minus the square root of, take the b, which is negative 2 squared, minus 4 times the invisible 1 times negative 64. You want to make sure that everything is listed under the square root that should be, and likewise that it looks as if we're dividing by the entire expression. So if I clean that up a little bit, I'm going to take the opposite of 2, which is 2. In the denominator, I'll go ahead and do that pretty quickly as well, 2 times 1. And over here, if I need to, I can calculate on my calculator that 2 squared is 4. 4 times 64 is 256. So I end up with the square root of 260 total. Now, if I'm looking to give an exact answer, then I would want to break this 260 down into a smaller square root. So in order to do that, I would realize that 260 divides by 4, leaving me with 2 root 65, all divided by 2. And finishing this as an exact, I'm going to end up realizing that the 2 from the denominator divides into the original 2, and the 2 that is in front of the root 65, simplifying to 1 plus or minus root 65. But in terms of my answers, what I want to do is I actually want to separate those. So I want to make sure that I start by writing them as distinct answers. 1 plus root 65, and then 1 minus root 65. So certainly on an initial glance, I would think that both of those are solutions. But what I want to do is actually calculate their answers, so use your calculator and figure out what their approximate value is. Because there's one other thing that we haven't yet seen in some of the problems that is going to come into play here. So as I go to approximate it, I'm going to see that for the first one, where it was a sum, I'm going to get approximately 9.062. And then for the second one, where it was a subtraction of 1 minus root 65, I'm going to get a negative 7.062. Now, we also could have estimated that, right? 65 is close to square root of 64, 1 minus 8, right? So 1 minus 7, be approximately negative 7. The reason that having an idea on whether or not those solutions are positive or negative is because I want to check for extraneous solutions. It was in the directions to begin with, but this is the first problem where we've needed to use that concept of extraneous. Extraneous means I did a lot of work, and I came up with some answers, but that one of those answers doesn't actually work in the original equation. And so what happens is, to be honest, on this problem, this negative, if I were to put that negative 7 in here, I'd be taking the log of a negative. And if you think about the domain for this portion, the domain goes from 0 to infinity. And so having a negative, the log of a negative, is an extraneous situation. So I'm going to have to throw that out in both its approximated form and its exact form, because neither of them work. So these are considered extraneous, and we throw them out. You definitely should have written them and crossed them out, though, so that I know that you have considered them. And then we'll go back and we'll relabel that this is our only exact solution in this problem, and this is our only approximate solution, because the others were thrown out.